All right, hi boys and girls. All right, we're going to graph the data from Nick's walk that went from the 8 meter card on back to the 0 meter card. So I have the data that we collected, and I also have the graph all laid out to make our video a lot faster. All right, as you recall, I have the distance on the y-axis, the time on the x-axis, and that's how we will always set it up. Now, we're going to turn our data table into coordinates. And just as I was reminding you yesterday, keep in mind that the x coordinate is always for time, right? And the y coordinate is always for distance. When you're graphing the x coordinate, you're always going to the right, crawling right before you climb up. So the first number on our data table are 0 and 8. So our coordinate is 0, crawling over 0, climbing up 8. Then we have 3, 7, 5, and 6. We have 7 and 5. We have 9 and 4. We have 12 and 3. We have 14 and 2. And 15 and 1. And 18 and 0. Back to 0 distance. So as you recall in Nick's walk, he started, instead of starting at 0 by the refrigerator, he started at 8 by the sliding door. And so that makes a different shape form on your graph. Let's see what it looks like. All right, so the first coordinate is 0, 8. Now on all the other graphs, our very first coordinate was here at the corner, but this time it's 0, 8. So we are crawling over 0. We're staying right here on the 0 line, and we're climbing all the way up on the 0 line right to the 8. Our first coordinate is at 0 to the right, 8 up. All right, our second coordinate is 3 seconds and 7 meters. So we're going to crawl over to 3 seconds, and we're going to climb up to 7 meters. Next is 5 and 6. We're crawling over to 5 seconds, and we're climbing up to 6 meters. The next one is 7, 5. We're going to crawl over to 7, and we're going to climb up to 5 meters. The next one is 9, 4. We're going to crawl over to 9 seconds and climb up to 4 meters. Then we're going to do the next one, which is 12, 3. We're crawling over to 12 seconds and climbing up to just 3 meters. Then we're doing 14, 2, crawling over to 14 seconds and climbing up to 2 meters. And 15, 1, crawling over to 15 and climbing up to 1. And last, we're going to 18, crawling over to 18 and climbing up to 0. Now, you can see that it makes a semi-diagonal, not a perfect one. Our attempt to walk in a completely constant speed is always a little difficult to capture. So what I'm going to do is I'm just going to connect 8 to 0, so you can see that follows the line of the points pretty well. There's only one or maybe two that's not pretty much right on there. All right, so do you see how the slope of the diagonal turned out? I'm asking you while I make another line for it, is this diagonal a very steep diagonal? Or is it kind of a flat diagonal? Right? Remember, it took 18 seconds to do this walk, and we were only going 8 meters. You could do that in hardly any time at all, especially if you were running. So I see that the slant isn't too steep. Now, it's not as flat as it could be. If I could have gotten Nick to walk even slower, we could have made it go, like that, right? We could have started at 8, and then we could have made it go way out and take way longer. And if we made it take way longer, think about this. Let's say that Nick took the walk in 21, 2, 3, 4, 5, 6. He did 26 seconds. Look at how that slope would be. I think it'd be even less steep. Let's show you. Imagine that. See, that's even less steep. So the longer it takes to do the walk, the flatter the slope gets. Also notice that this time we started away from home. Now, if we eventually start working on Study Island a little bit more, there's a question in Study Island that is just like this, and the question is like it's like a Bobby rode a skateboard from the end of the driveway back to his front door, and um, and then showed a graph that looked like this. This would be the end of the driveway, like over by the sliding glass door, away from the refrigerator, which was the starting point for all our videos yesterday, and rode back to the house. That would be kind of like a word problem for this kind of a question, right? Now, sometimes they'll give you a weird distractor that asks you if you're going down a hill, and I need you to know that this is not going down a hill. You saw what Nick did in the video. All he did was walk slowly from 8 meters back to 0, but he did it in 18 seconds. So a distance over time graph cannot tell you whether the land is hilly or whether the land is flat. The distance time graph shows you the distance traveled and the amount of time it took, which lets you get an idea of a slow speed or a fast speed by looking at the slope of the line. All right, good job, y'all, and we'll stop there for this one. See you in about a minute.